I will start the discussion with this point. What is procedure for finding the current and voltage using the Triset matrix? What are the steps we have to follow? First, we have to draw the oriented graph for the given network. Then we have to select a tree and we have to prepare the Triset matrix, which is BF. Construct the branch impedance matrix ZB for the network given below, and then we have to prepare these equations and so on. Is it right? Now I will come one by one to these steps, and we will try to resolve, or we will try to solve the problem which is based on this. If I'm going back to the equilibrium equations, look at how should be the standard branch in this case. Each branch must consist of impedance and source. That is mandatory in case of the Triset matrix. If we are using the Triset, branch must be in terms of impedance and voltage source. Is it right? I will come back to you. And we will discuss here. Now, here in this case, we are interested in the calculation of the current. We are interested in the calculation of the current using the Triset matrix method for this given network. Is it right? It doesn't matter how the network is complicated. What matters? It matters is if you are aware of the matrix multiplication, the things are not complicated. Is it right? First, what I will do, this is resistance and its voltage source. This is resistance, voltage source, but this is resistance and current source. I will convert this current source into the voltage source, as well as I will convert this current source to the voltage source, this current source to the voltage source, and finally this voltage source to the current source, because in this particular method, whatever the method I have discussed, in that particular method, it is always recommended that each branch must be in this format. Each branch must be in this format. There is impedance followed by its voltage source. Current sources, if are available, we have to convert those current sources into the voltage sources. Let's look at how is the figure for this case. That is step number 1, which is we will modify the figure, or we will draw the standard figure for this case. Modification of the figure. Modification of figure. Here it is required because whatever the equilibrium equations we have discussed, those equations are in terms of the standard. Okay. Just I will draw. This is one node. This is the second node. This is the third node, and it will be the fourth node. Here is one branch having its resistance and voltage source. This is one node. Then here again it is the voltage source. This is positive. This is voltage source followed by the 2 ohm resistance. This I am drawing this 2 ohm and 6 ohm. Here it is 2 ohm and this is 6 volt. This is plus and this is minus. It is 10 volt. This is minus and plus. This is 10 volt. Is it right? Its resistance is 2 ohm. Right? Then I will convert this current source into the voltage source. If we are converting that current source to the voltage source, it will be something like this. This is negative and this will be the positive because its direction is downward. This is another node. Here in this case, this current source will be converted into another voltage source. Here its voltage source will be something like this. This will be the negative and this will be the positive. This is another branch. Again, I will convert this current source into its equivalent voltage source. It will be something like this. This is negative and it will be positive. It is something like this. And finally, I will convert this current source into its equivalent voltage source. That figure will be something like this. This is negative. This will be the positive. And here will be the resistance. And I will come back to this terminal. Is it right? And in this case, if I am drawing the nodes, this is one node. I will call it as node A. Is it right? This will be the node B. I will call it as node B. This is the node C. And finally, I will call it as node D. Is it right? At the same time, we will give the suitable direction for each branch. Suitable direction for each branch. In this case, as well as first, I will find out the values. What are the values? Its value is, its resistance is 6 ohm, no doubt. This resistance is 3 ohm. This resistance is 2 ohm. and again this resistance is 2 ohm. How much is the value of this voltage source? This is V is equal to I into R. 6 into 3. Is it right? 6 into 3. 18 volt. Is it right? This is 18 volt. This is minus and this is plus. If I am doing the wrong calculation, please remind me. Is it right? In this case, this voltage source, its value will be I into R, that is 5 into 3. That is 15 volt. This is 15 volt. This is minus, it is a plus. Is it right? Similarly, how much is the value of this source? 5 into 2, that is 5 to the 10. This is 10 volt. It is direction is upward, that's why this will be the minus and this will be the plus. Finally, the value of this source is 3 to the 6. 6 volt, this is again minus and this is the plus, that is the case. Is it right? I will give the names to the branches. This is the branch number 1. I will give its name. This is as the branch number 1. This is the branch number 2. I will give the name of this branch is the branch number 3. This is the branch number 3. Here it is the branch number 4. This is the branch number 5. And this branch is the branch number 6. Is it right? I have given the names to each branch. Then I will assume the suitable current for each branch. Is it right? In this particular case, I will assume this current to be forward. In this case, this current is again forward. This current I will assume it has a forward again. This is forward. In this case, this current I will assume it has a downward. I will assume this current as again downward. And in this case, I will assume this current also in the downward direction. There is no logic behind it. You can assume the directions of the current randomly. This is forward, forward, forward. This is downward. This is downward. Something like that. Is it right? Assume any random direction. But whatever the directions you have chosen, whatever the directions you have assumed, those directions should be the same as far as the solution of this complete equation or this figure is concerned. Is it right? This first is we have modified the figure. The second point in this particular case is we will draw its oriented graph. Oriented graph or directed graph. First, we will draw its graph. Is it right? This is graph. In this case, how many nodes we have? Now look at how is the procedure for drawing the graph. Here, look at, in this case, 1, 2, 3, 4, we have the 4 nodes. This is 1, this is 2, this is 3, and it is 4. We have the 4 nodes. I will give the names to the nodes. This is node A, this is node B, this is the node C, and this is node D. एक branch की जगह एक line आएगा. Are you getting me? For each branch we are drawing one line, and in that case sources are replaced by its interrelations. In this case, all sources are the voltage sources. That's why these voltage sources are replaced by its interrelations. This figure will be something like this. Here is one branch. This is another branch. This is first. This is second. Is it right? Otherwise, I will start from the branch number 1. This is the first branch. This is branch number 1. This is branch number 2. This is branch number 3. Here it is. This is the branch number 4. This is the branch number 5. And this is the branch number 6. I will show the directions also. Here, this is forward. Means it is branch number 1. Its direction is a forward. This is branch number 2. Its direction is a forward. Another branch we have, which is the branch number 3. This is branch number 3. Its direction is again forward. This is branch number 3. This is branch number 4. Its direction is downward. This is the branch number 5. Its direction is downward. And then finally, we have, this is the branch number 6. Its direction is again downward. Is it right? And whatever this graph we have, this graph is known as oriented graph or directed graph. What is the first step in this calculation? Look at carefully. Here we have, this is node A, this is node B, this is node C, and this is our node D. We have these 4 nodes. Now look at what is the step number 1. Step number 1 in this particular case, if I'm coming back, yeah, this is Draw the oriented graph. We have completed this first part, oriented graph. Then what is the second step? Select a tree and prepare the Triset matrix. Second step is select a tree and prepare the Triset matrix. Is it right? So here in this case, I will use the second step. In this case, Miss, here we will use the third step to be exact here. That is preparation of the Triset matrix or first Trisets. Is it right? Now this is the oriented graph. What I will do, I will use the next step, which is the step number 3. Just wait. I will use the step number 3. This is the oriented graph we have. Now in this case, I will use the step number 3, which is step number 3 is nothing but preparation of the Trisets or selection of tree and Trisets. Selection of tree and formation of Trisets. Selection of a tree and formation of Trisets. Now here, in this case, we have A, B, C, D, 4 nodes. I will draw the nodes first. This is node A, this is node B, this is node C, and this is the node D. Is it right? This is my node A, this is node B, this is node C, and this is the node D. Out of these 4 nodes, now select a path which will connect all the nodes or directly or indirectly without forming the loop. In this case, they have not given the tree, but they have given the flexibility to assume the tree ourselves. Now here for this figure, if I am taking this branch number 2, branch number 3 and branch number 5 as a tree, means it is something like this. This is one branch, this is the second branch, and this is the third branch. Is it right? If it is not given, then we have the choice. This is the branch number 2, this is the branch number 3, and this is the branch number 5. This we are selecting it as a tree. If it is selected as a tree, then we will form the Trisets. Is it right? If we have selected this is as a tree, then we will form the Trisets. Now look at how are the Trisets. We will form the Trisets. Now I will start with the first point, that is Triset 1. Triset 1. How we are preparing the Trisets? Just recall. How we are preparing the Trisets? We are putting one cotree branch at a time, and there is a formation of loop, and that particular loop is known as the Triset. Means in this particular case, if I am coming to this figure, is it right? Now this is the tree which we have selected. If I am putting the branch number 4 here, this is the branch number 4, then it will form the closed path, that is nothing but our Triset number 1. Formation of closed path is nothing but the Triset if we are putting one cotree branch at a time. Means what I will do first, I will prepare the Triset number 1. Is this is one node, this is second node, this is third node, and this is the fourth node. Is it right? This is node A, this is node B, this is the node C, and here it is the node D. What we are doing, I am drawing the tree branch or tree as it is. This is the branch number 2, this is the branch number 3, and this is the branch number 5. Is it right? Just what I am doing, I am putting this fourth cotree branch. This cotree branch here. How is the direction of this current? Downward. What is the name of the branch? Which is fourth. Is it right? Now this is the Triset number 1. What is my Triset number 1? I will write here. This Triset number 1, that is T1 is equal to, we have the branch number, I will write here first. This is the branch number 5. This branch number 2, this my Triset number 1 is branch number 2, followed by branch number 4, followed by the branch number 5. This set of the branches is known as the Triset number 1. But how is the direction of the current in this closed path? The direction of the current in the closed path is very same as the direction of the core-tree branch. This is core-tree branch because this is the tree, this is core-tree, and its direction is downward, means in this particular case, this will be the loop current for first loop. I will call it as first Triset current, which is the IX. Is it right? This is first Triset current, which is the IX. Okay, fine. I will prepare the second Triset, that is Triset number 2. I will start from here. Is it right? Second, that is Triset second. Triset number 2. Because how many tree branches we have, or how many core-tree branches we have exactly? In this particular case, here 1, 2, 3 are the tree branches, means remaining 3 are the core-tree branches, means number of Trisets is equal to 3 in this particular case, because number of this Trisets is equal to the number of core-tree branches. If we have the core-tree branches 3, this Trisets will be 3. This is Triset number 2. What I will do? I will draw this tree as it is. This is node number first, this is second node, this is third node, and this will be the fourth node. This is my node A, this is node B, this is node C, and this node is the node D. This is node D. Is it right? How is the tree? Branch number 2, branch number 3, and branch number 5 is forming as a tree. Now I will come back to this figure. In this figure, what we have done? Already we have prepared the tree by using this core-tree branch. This is 1, 2, 3 is a tree. Means if I will use this branch number 6, if I will use this branch number 6, which is the core-tree branch here, this branch number 6, then again it will form the closed path. Means how is our Triset number 2? That is T2. This Triset number 2 is branch number 3, 5 and 6. Branch number 3, branch number 5 and branch number 6 is known as the Triset number 2. Triset is nothing but it is a group of branches which will form the closed path. Is it right? Now in this case, how is the direction of the loop current or direction of the Triset current? In this case, the Triset current is IY. This is the Triset number 2. That's why its current is IY, and this direction is same as this core-tree branch direction, which is downward. That's why we have taken this loop current as a downward. Is it right? I will come to that again. Then here we will prepare the Triset number 3 here. We will prepare the Triset number 3rd. If I am coming to this figure again, this is Triset 3rd. We will prepare the Triset 3rd because we have the 3 core-tree branches. Which branches we have taken? I will discuss here. This is 2, 3, 5 is the tree branch. That's why we have taken one Triset by using 4th branch, second Triset by using 6th branch. Now the third Triset will be by using the first branch. In this case, if I am drawing this figure something like this, this is the node number A, this is B, this is node C, and this will be the node D. In this case, this is one tree branch, second tree branch, and third tree branch. This is the branch number 2 forward. This is the branch number 3 again forward. This is the branch number 5 which is forward. Now in this case, what I will do? We will take this upper branch. We will take this branch number 1 as a third core-tree branch, and it will form again the closed path. Something like this. How is the direction of that branch? It is forward. That's why in this case, this is the branch number 1 and it is the forward. In this case, this Triset number 3rd, T3. This Triset number 3rd is branch number 1, branch number 2, and branch number 3 is the Triset number 3rd, and we will take its current as a third current, which is IZ. I will take the first Triset current is IX, second Triset current is IY, and the third Triset current is IZ. You can name this is first Triset, second Triset, third Triset, or you can name this is first, second, third, or whatever is the sequence, that is your choice. This year our aim is the selection of a tree. We have selected this as a tree, and the formation of the Trisets is we have prepared the three Trisets, Triset number 1, Triset number 2, and Triset number 3. If we have the Trisets, then we will prepare the next part, which is nothing but the Triset matrix, which is fundamental Triset matrix. I will write the next step, which is the step number 4. This is fourth step. I will go for the fourth step. This is my fourth step. Is it right? Now this is the step number 4. This is the step number 4. That is preparation of fundamental Triset matrix. Fundamental Triset matrix. How is that matrix? The name of that matrix is B stands for Triset. This F stands for fundamental. Fundamental Triset. The rows of this matrix are the Trisets. Triset number 1, Triset number 2, Triset number 3. Because we have 3 Trisets, as we discussed in this particular figure. We have the 3 Trisets. Is it right? Triset number 1, Triset number 2, and Triset number 3. And in case of this matrix, fundamental Triset matrix, rows of this matrix are the Trisets, are loop currents. And column are nothing but the branches. Branch number 1, branch number 2, branch number 3, branch number 4, branch number 5, and the branch number 6. These are the branches of the graph, or branches of the figure are nothing but the columns of this particular matrix. Columns of this particular matrix. Columns of this particular matrix. Now here I will prepare this matrix, and we will find out the values. I will come back to you. Yes. Now here in this case, if I'm coming to this figure, otherwise just give me a minute, I will be coming back to you. Just a minute. Yeah. Here. This is the Triset. Number 1, T1. Now look at how will be the entries into the matrix. If this current and this current has the same direction, entry will be +1. If it is opposite, entry will be -1. And if that branch is absent in that particular Triset, then its entry will be 0. This here, if I'm trying to discuss here, in this case, how are the entries for Triset number 1? Look at this branch number 1. Where is the branch number 1? Just I will show here. Just wait. Just give me a minute. I will come back to you with branch number 1. Yeah. Just a minute. Yeah. In this case, if I'm coming to the original figure, this is the branch number 1. And the branch number 1 is the upper branch, which is not the part of this particular Triset. That's why its entry for this particular branch number 1 will be 0, because branch number 1 is not the part of this loop. Branch number 2. This is branch number 2. Its direction is opposite to that of this direction, because it is forward and this is backward. That's why for the branch number 2, its entry will be -1. How is the entry for branch number 3? Branch number 3 is not the part of this Triset. That's why its entry will be 0. How is for branch number 4? Branch number 4 is direction and this loop current direction or Triset current, both are the same. That's why its entry will be +1. Branch number 5, it is downward direction and this current is upward, which is the loop current or Triset current. That's why again its entry will be -1. And finally, the branch number 6, which is somewhere here, that is not the part of that I said, that's why its entry will be 0. Is it right? Then I will make the entries for Triset number 2. I will make the entries for the Triset number 2. How are the entries for the Triset number 2? Now look at. For the Triset number 2, I am coming here. This is the Triset number 3rd. If I am coming to the Triset number 2, which is this. This is the Triset number 2. Is it right? This is T2. If I am discussing about the T2, in this case, branch number 1 is not the part of this Triset or part of this loop. That's why its entry will be 0. Branch number 2 is not the part of this. Branch number 3 is a part of this loop, and its direction is same as the direction of this loop current. That's why its entry will be +1. Branch number 4 is not the part of this loop, which is 0. Branch number 5 is a part of the loop, but its direction is downward, whereas this loop current is upward. That's why the entry for the branch number 5 is -1. Entry for the branch number 5 is -1. Similarly, if we are checking for the branch number 6, both the directions are same. That's why entry for the branch number 6 is the +1. Those are the entries. Is it right? Similarly, if I'm coming to the Triset number 3rd, which is here, Triset number 3rd. This is 3rd Triset. In this case, this is the branch number 1. Its direction is same as this loop current direction. That's why for the branch number 1, its entry is +1. Branch number 2, its direction is opposite to that of this loop current direction, means its entry is -1. Branch number 3, its direction and direction of this current is opposite. That's why its entry is -1. And branch number 4, branch number 5, and branch number 6 is not the part of this loop, or it is not the part of that Triset. That's why those entries will be 0. And this is the step number 4, which is, just a minute. This is the step number 4, which is the preparation of the fundamental Triset matrix. This is the step number 4 in which we are preparing the fundamental Triset matrix. If we know the fundamental Triset matrix, what is the next step? I will show the step number, and I will come back to this figure. Here, look at. Construct, this is select the tree and prepare the Triset and Triset matrix. Construct the branch impedance matrix ZB. Now here, in this case, we are planning for the preparation of the impedance matrix, which is ZB. Here, this is the step number 5. Preparation of the branch impedance matrix. Preparation of branch impedance matrix. This is right. Branch impedance matrix. Now we will prepare the branch impedance matrix. Now look at how will be the branch impedance matrix. That I will discuss here. In this figure, we will prepare the ZB, branch impedance matrix. How is this ZB? This branch impedance matrix is a matrix of order B by B, or B cross B. If we have 1, 2, 3, 4, 5, 6 branches, this order of this matrix will be 6 by 6. What is the impedance of the first branch? Impedance of the first branch is the 2. How will be the entries? It will be something like this. This is 2, 0, 0. It is 1, 2, 3, 4, 5, 6 because it is Z11. Impedance of the first branch. Impedance which is common for the first and second is 0, and so on. Is it right? Similarly, How much is the impedance of the second branch? Look at here. This is the second branch, 2 ohm. This is again 0, 2, 0, 0, 0, 0. Impedance of the third branch is again 2 ohm. Is it right? That's why again it is 0, 0, 3, 0, 0, 0. Means only diagonal elements will present in this particular matrix, ZB. Then branch number 4. This is branch number 4. How much is this impedance or its resistance? 6. The 0, 0, 0, and this value is the 6. Next, how much is the impedance of this branch? Remaining are zeros again. Branch number 5, it is 3 ohm. This branch impedance. We are not interested in source. I will see about the source later on. This is 3 ohm. It is 0, this is 0, this is 0, this is 0, it is 3, and this value is again 0. Yes. Finally, for the branch number 6, its entries will be this is 0, this is 0, this is 0, this is 0, this value is 0, and the impedance of this branch is the 2 ohm. Is it right? This is the preparation of the branch impedance matrix. I will come back to you. I will discuss these 2 points first. Initially, I will discuss these 2 points first, and then I will proceed further for the calculation of the next parameter, which is as per the guidelines which are available with us. In this case, we have drawn the oriented graph. We have prepared this matrix, which is BF. We have constructed this ZB. Now, we will find out this ZT by using this relation BF into ZB into BF transpose. Is it right? Now, we will prepare, that is, Triset impedance matrix. Preparation of Triset impedance matrix. Triset impedance matrix, which is ZT. ZT. Which is equal to, what is the expression for ZT? This ZT is equal to, here, this is BF matrix into matrix ZB into matrix BF transpose. Into that matrix BF transpose. Look at BF into ZB into BF transpose. The same thing I have taken. BF into ZB into BF transpose. Now I will try to find out this ZT, which is equal to, this is matrix, which is equal to, I will copy the first matrix, which is, the fundamental Triset matrix, which is this fundamental Triset matrix. I will copy this. How is the fundamental Triset matrix? Here it is 0, this is -1, this is 0, it is +1, this is -1, and this is 0. Is it right? This is 0, this is -1, this is 0, this is +1, this is -1, and this is 0. Second, this is 0, this is 0, here it is +1, then 0, then it is -1, then +1. Is it right? The second, it is a +1, this is -1, then it is -1 again, then it is 0, then it is 0, then it is 0. This is that matrix, which is BF. Then I will take the ZB. I will take the ZB, which is the branch impedance matrix, which is this. This is ZB. I will take this ZB here. How is our ZB? I will copy this. I will copy this ZB. Otherwise, I will just give me a minute. I will be here to give you the things in the proper way. Look at here. This is ZB into this ZB. I will put here. This is matrix. This is 2, 1, 2, 3. This is 4, 5, 6. Is it right? Then 0, 2, 1, 2, 3, 4. This is 0, 0, 3. Then 0, 0, 0. It is 0. Then 0, 0, 0, this is 6, then 0, then 0. Then it is 0, 0, 0, this is 0, this is 3 and 0. And finally, this is 0, 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 and this is 2. This is the preparation of the ZB. Just I have copied here. The ZB I have copied here. Is it right? Nothing else. Into BF transpose. Transpose of this matrix. How is the transpose of this matrix? I will draw here. Just we are converting rows into the column. This is 0, then we have the -1, then 0, then 1, then -1, and then 0. Is here just this is 0, -1, 0, this is 1, -1, 0. Finally, the next step is 0, this is 0, this is 1, this is 0 again, this is -1, and this is 1. I will check once again. 0, 0, it is 1, 0, -1, and then 1. And finally, this will be 1, this is -1, this is again -1, it is 0, 0, 0. This matrix is the transpose of fundamental Triset matrix, which is BF transpose. This is ZT is equal to BF into ZB into BF transpose. What I will do? I will keep this matrix as it is. I will keep this matrix as it is. 0, -1, 0, 1, -1, and 0. This is 0, 0, this is 1. Then we have 0, this is -1, this is 1, this is 1, this is -1, -1, 0, 0, 0. This matrix is the BF matrix. If there are the calculation error, please remind me. 0, -1, 0, 1, -1, 0. This is 0, 0, 1, 0, -1, and 1. Then 1, -1, -1, 0, 0, 0. Fine. We will find out the multiplication of the two matrices. Multiplication of these two matrices. It's multiplication. Now look at how is the multiplication part that I will try to discuss. How is the multiplication? This is 2 into 0. 0 plus, sorry, this is 0 plus 0 plus 0 plus 0 plus 0 plus 0. Means the first value in this particular case is 0. Is it right? First row, first column, first element. Is it right? Then we will check about. Now here in this case, first row, second column. This is 2 into 0 is 0, 0, 0 plus 0 plus 0 plus 0. This how is the second element? This second element is also 0. Now look at this row, last column. 2 into 1 is 2 plus 0 plus 0 plus 0 plus 0 plus 0. This value is the 2. This multiplication of these two elements plus multiplication of these two elements and so on. Just I am doing the oral calculations, nothing else. If I am going for the row number 2, this row and first column. This is 0 into 0, 0. 2 into -1 is a -2 plus 0 plus 0 plus 0 plus 0. Means the next value is, it is -2. This is -2. This row, this column. 0 into 0 is 0. 2 into 0 is 0. Then 0, then 0, then 0, then 0. This here, this element will be 0. You're getting me? Multiplication of this row and the last column. 0 into 1 is 0. Then 2 into -1 is -2. And all remaining elements are 0. Means it is -2. Are you getting me? Then this row and first column. 0 into 0, 0. The 0 into -1 is 0. Then 3 into 0 is 0. And all the remaining elements are 0. And this 0 into anything will be 0. This entry will be 0. Is it right? The next. In this particular case, the next entry will be something like this. Are you getting me? Just wait, just wait, just wait. I did little while copying or while drawing the figure, branch number 3. Yes, I did the mistake in ZB. I will correct it and then I will proceed further. I will show the figure. I will do the correction. Here look at This branch number 3, how much is this impedance? Its impedance is 2, but by mistake I have taken it as a 3. Is it right? This is for the branch number 5 is a 3. For branch number 3, its impedance is a 2. This value should be 2. Is it right? This is 2. For branch number 2, it is 2. Branch number 3, it is 2. Branch number 4, it is 6. Branch number 3, it is 5. It is a 3. And finally, for this branch, it is 6. Now it is fine, I guess. This is branch number. ZB is for the branch number 3, it is 2. This value is 2. Okay, fine. Now here, how is this multiplication? 0 into this value is 0. This is 0. This is 0. And everything is 0. That is the first element. Second, this is 0 into 0 is 0 plus 0. This is 1 into 2 is 2. And then remaining are zeros, means plus 0. This value is the 2. Is it right? Then this row in this column, 0. This is 0. This is minus 2 and remaining are zeros. This is again minus 2. This is again minus 2. Is it right? Then this fourth row, first column, 0. This is 0. This is 0. This is 1 into 6 is a 6 and remaining are zeros. This is plus 6. This is plus 6. Then this row, second column. This is 0 into 0, 0. This is 0. This is 0. This is 0. Remaining are zeros. This value is 0. Then again, this row and last column, this is 1 into 0. This is 0 into 1 is 0. This is 0 into minus 1 is 0. The 0 into minus 1 is 0. The 6 into 0 is 0. The remaining are zeros. This value is also 0. Is it right? The next is this column number, row number 5 and column number 1. This is 0 into 0 is 0. This is 0 into minus 1 is 0. 0 into this value is 0. Then it is 0. 3 into minus 1. This is minus 3 and this is 0. This element will be minus 3. Is it right? That element will be minus 3. Then this fifth row and second column, this is 0, this is 0, this is 0, this is 0, and this is 3 into minus 1 again. That value is again minus 3 and this is 0 again. This value is again minus 3. And finally, this row and last column is 0, this is 0 into that again 0. The next, it is 0. The next 0 is 3 into 0 is 0. And this value is 0. This last element in this particular case is the 0. Last element in this particular case is again 0. Finally, this last row and first column, only all these are zeros. That's why anything into 0 will be 0. And finally, this 2 into 0, this value will be 0. Again, this row and this column, all these will be zeros. Multiplication of these will be zeros. This is 2 into 1 will be its multiplication, which is 2. And finally, this into this, look at these are 5 zeros multiplied with this value 0. And this is 2 into 0, that value will be 0. This is multiplication of those matrices. Is it right? Then, next, in this case, we will try to find out the final elements of this matrix, which is ZT. Final elements of this matrix. Look at this first row and first column. How are the values? How are the values? This is 0, minus into minus, that is a plus, 2 into 1, I will write somewhere here. This is 2, then 0, then it is plus 6, then it is minus into minus, that is a plus. 3 into 1 is plus 3. Is it right? How much is this value? I will check once again. This is 0. Minus 1 into minus 2 will be plus 2. The next 0. Then plus 6. Then plus 3. This value is 6 plus 3, that is 9 plus 2. That is 11. I guess this first element is the 11. How is the second? This row and second column. This is 0, this is 0, this is 0, this is 0 again. This is minus into plus is a plus and its value is 3. Then it is 0. The next value is the 3. This is 3. Is it right? Then first row and last column. This is 0. This is minus into minus, that is plus 2. That value is a plus 2. Is it right? Then 0, then 0, then 0, then 0 means its value is plus 2. 11, 3, 2 is the first row. How much is the second row of this particular matrix? 0 into 1, sorry, 0 into 0 is 0, this is 0, this is 0, this is 0, this is minus into plus, sorry, minus into minus, that is plus. 1 into 3 will be 3, that value is 3. This value is a 3 and finally it is 0, this is next element is the 3. Second row, second column. 0 into 0 is 0, this is 0, this is 2. 1 into 2 will be, this is 2. This is 1, 2, 3, 1, 2, 3, this is 2. Then this is 0, this is minus 1 into this minus 3 will be plus 3, will be plus 3, this value. And finally 1 into 2 will be plus 2. How much is this value? 3 plus 2, 5 plus 2, that is 7. This value is, I guess it is plus 7. This value is the 7. Similarly, if we are taking second row and the last column, 0, this is 0, this is minus 2. This will be minus 2. Is it right? This is minus 2. Sorry. Where I was, this is 0, this is 0, this is minus 2, then 0, then 0, then 0. This next element is the minus 2. This element is the minus 2. Is it right? Next. The last row, first column, 0. This is minus into minus, that is a plus, plus 2. This value is a plus 2. This is plus 2. 0, then 0, then 0, then 0. Means its element of this particular case is the plus 2. Is it right? Then last row, second column. This is 0, this is 0. This is minus 2. This is minus 1 into this 2. It will be minus 2. This is minus 2. Then 0, then 0, then 0. This is minus 2. This here it is minus 2. And finally, this last row and last column. This is 1 into 2 is 2. This is 2. This is 2. This is minus into plus will be plus 2. This is 1 into 2 will be 2. Then it is again plus 2. Again plus 2. Is it right? Then 0, then 0, then 0. This value is the plus 6. It is the plus 6. This is the preparation of the ZT, which is nothing but Triset impedance matrix. This is the Triset impedance matrix. If we know the Triset impedance matrix, now look at how is the next step or what is the next step. Prepare the Triset impedance matrix ZT using the equation we have prepared this matrix. I will go to the next figure. Prepare the voltage source matrix. Prepare voltage source matrix, which is Vs, which is equal to how many elements this matrix must consist of? 6. Vs1, Vs2, Vs3, Vs4, Vs5 and Vs6. How it is Vs6? Because we have the 6 branches. I will discuss. I will show. These are the 6 branches which we have. These are the 6 branches. Just a minute. I will discuss. I will show this figure. Here, look at. We have the 6 branches. This is branch number 1, branch number 2, branch number 3, branch number 4, branch number 5, branch number 6. And each branch, there may be the source or there may not be the source, and accordingly we are preparing this matrix. Now look at how will be this case. If I am preparing this matrix, how will be its sign? What factor will decide whether it is a plus entry or whether it is minus entry? Whether it is plus entry or minus entry, who will decide? I will just come back to the PPTs. I will discuss the rule. What is the rule? The elements in the Vs or voltage source matrix are taken as a positive. कब positive लेना है? If branch current enters the positive terminal of the voltage source. Means if the branch current enters the positive terminal of the source, तब positive लेना है. अगर negative terminal में आता है तो negative लेना है. For this first branch, the current enters into the negative terminal. This is direction of the current we have taken forward. Current enters into the negative terminal for the branch number 1. That's why its entry will be -6. For the branch number 2, this is forward direction. How is the current? Current entering into the positive terminal, then it is taken as a +6 because it is 6 volt. Is it right? Then here positive to negative. In this particular case, now look at current enters into the negative terminal. That's why for the branch number 3, this entry will be -10 because it is 10 volt. For branch number 5, look at this assumed current. It is entering into the negative terminal of the battery. That's why the value of this source or value of this branch source, which is 4th, it will be minus how much? It is 18. This is -18. VS4. How is VS5? In this case again, the current is downward. It enters into the negative terminal of the battery. And the value of the source is -50. In this case, it is downward. In this case, current is downward. Look at how is the current. Current is entering into the positive terminal of the battery. That's why this entry will be +10. This entry will be +10. If we are preparing this matrix VS, look at what will decide that entry will be positive or that entry will be negative is nothing but if the current is entering into the positive terminal of the battery, then that entry will be plus, otherwise that entry will be minus entry, and this is the preparation of the VS, which is the step number 7. Is it right? If we have the step number 7, then we will prepare the step number 8. I will discuss what is the step number 8. Step number 8. Now look at the step number 8. If we have this, prepare the KVL equation or equilibrium equation using ZT into IT is equal to -BF into VS. Yes, here the step number 8 is I will draw somewhere here. I will draw somewhere here. This is the step number 8. Step number 8. Preparation of the KVL equation. Preparation of KVL equation or equilibrium equation. Equation. How is that equation? Now look at it. That equation is ZT into IT. This ZT into that IT. What is ZT? This is Triset impedance matrix. IT is a Triset current matrix, which is equal to -BF. This is -BF into that VS. Is it right? This is matrix. Now I will discuss each point one by one, and first we will prepare, and then we are in a position to find out this value of the IT. That is nothing but the loop currents, or that is nothing but the Triset currents. First, I will take the ZT, which we have prepared. I will take the ZT. Just a minute. ZT. I'm coming back. Look at this ZT, which we have calculated. This is ZT. I will copy the ZT here. I will copy this ZT. Is it right? Now, in this case, this ZT is nothing but this value 11, 3, 2, 3, 7, -2, 2, -2, 6 is the ZT. We are interested in the calculation of this IT. Triset currents. How many Trisets we have? How many Trisets we have? We have the 3 Trisets. Is it right? This is Triset number 1, Triset number 2, and Triset number 3. This current is IX, IY, and IZ. Which we are interested in the calculation of Triset current 1 Ix, Triset current 2 that is Iy, and Triset current 3 which is Az is nothing but indirectly we are interested in the loop currents. We are interested in the loop currents. Is it right? Then into BF. BF is nothing but in this case which is the fundamental Triset matrix. Fundamental Triset matrix. This is minus. This is minus. I will write here the BF. In this case, this is the BF, which is fundamental Triset matrix. This is the fundamental Triset matrix. I will copy this. This minus sign as it is, I will copy this. I will copy this. This is 0, minus 1, 0. This is plus 1. This is minus 1 and 0. Is it right? The next column, so next row, 0, 0. This is plus 1. This is 0. This is minus 1. This is plus 1. The next, it is plus 1. This is minus 1. This is minus 1. 0, 0 and 0 is this matrix which is fundamental Triset matrix. Just I will check the entries once again. This is 0, minus 1, 0, 1, minus 1, 0. Okay, fine. The 0, 0, 1, 0, minus 1, plus 1, fine. Plus 1, minus 1, minus 1, 0, 0, 0. I guess absolutely fine. Then into Vs, voltage source matrix. I will copy the voltage source matrix which we have prepared. How is the voltage source matrix which we have prepared? Just I will show that matrix. Just this is the Vs, voltage source matrix. Is right. This is minus 6, plus 6, then minus 10, minus 18, minus 15, and plus 10. This matrix is the voltage source matrix. This matrix is the voltage source matrix. Now look at what we have prepared. We have prepared this equation. Now we will find out the multiplication of these two matrices. This thing as it is. This thing as it is. Is it right? This is equal to, I will find out its multiplication. Is it right? How will be its multiplication? It will be something like this. Now look at, I will write somewhere here. This 0 into minus 6 is 0. This is minus 1 into 6 is minus 6. This is minus 6. This is 0. This is minus 18. This is minus 18. This is minus 18. Then this is plus 15. Minus into this minus 15. Means it is plus 15. This value is a plus 15. That's 0. Which is equal to, how much is this value? Minus 10. This value is just, I will check it out. Just I will check it out. This is 0. I guess this is 0. This is minus into this 6. This plus 6. This is minus 6. Is it right? Minus 6 minus 18 plus 15. Is it right? How much is this value? If I'm using the calculator, this value is minus 6 minus 18 plus it is 15, which is nothing but minus 9. Is it right? This value is minus 9. Here is minus sign again. This minus sign as it is. Just I'm finding this multiplication. The second. This is 0, this is 0, this is minus 10, this is minus 10, this is 0, this is minus into minus, that is plus 15, this is plus 15, and then this is 1 into 10 will be plus 10. Is it right? How much is this value? This minus 10 and plus 10 means its value is plus 15. This is plus 50. Is it right? That value is the plus 50. If we are taking this last row and this last column, this is minus 6. This is minus 6. This is again minus 6 because minus 1 into plus 6 is again minus 6. This is minus into minus is 10 plus and this value is a 10 plus 10. Then 0, then 0, then 0. This here, in this particular case, this value is minus 12 plus 10 is minus 2. This value is minus 9 plus 50 and that minus 2. If we are multiplying by this minus sign, its value will be 9 plus 9 minus 50 and plus 2. Is it right? this value. And this is very same as this term, that is 11, 3, 2, 3, 7, minus 2, then 2, minus 2, and 6. And these are the currents. Here, Ix, Iy, and Iz, which is equal to this value. Means here 11 Ix, 3 Iy, 2 Iz is equal to 9, and so on. So what I will do, I will use the calculator directly, and I will find out the value of current Ix, value of the second Triset, which is Iy, and value of the third Triset, which is Iz. Now look at how will be the values. I will use this calculator. First, I will shift the calculator in the equation mode. Number of unknowns, I will select the 3. First value is 11. Second value is 3. Next value is 2. And its constant is 9. Its constant is 9, not minus 9. This is 9 is the constant. Is it right? A2, this value is 3. Next is 7. Next is minus 2. And its constant is minus 15. Is it right? The A3 is 2 again. Then it is minus 2. The next value is 6. And its constant is 2. Its first value is 2.02. Ix is 2.02 amperes is the first current. Is it right? The next current Iy, it is minus 3.43. This is minus 3.43 amperes is the Iy. And finally, the next value, that is Iz, that is minus 1.48. Minus 1.48. This value is minus 1.48 amperes is that value. This indirectly, what I mean to say, we have calculated these loop currents or Triset currents. First Triset current, that is Ix, is 2.02. Second Triset current is minus, it is 3.43. And the second Triset current is minus 1.48 amperes. Means here in this case, if I am talking exactly, this is Ix. This current is found to be 2.02. The second current, this current is found to be minus 3.43, and this last current, which is the Iz, that current, it is found to be minus 1.48 amperes. If we know these loop currents, then we can find out the branch currents, and we can use this relation, which is the step number 9. I will use the next step, which is the step number 9, for the calculation of the branch currents. This is the step number 9, that is the calculation of the branch currents. Calculation of branch currents. How is the equation for the calculation of branch currents? I will show that first. How is the equation? Look at. This IB is nothing but BF transpose into IT. This IB is equal to BF transpose into IT. What is IB? IB is the branch current matrix. It is column matrix. How many branches we have? 6 branches. This is I1, I2, this is I3, it is I4, this is I5, and it is I6. If we have the 6 branches, this will be the branch column matrix, which is IB. BF transpose. The transpose of fundamental Triset matrix. Transpose of fundamental Triset matrix. I will show here. Just give me a minute. Yeah. In this case, we have taken, this is BF transpose. Just I will copy it. Transpose of the BF matrix. Is it right? How is that? This is 0. This is minus 1, 0. Then it is 1. Then minus 1 and 0. The next, it is 0, 0, 1, 0, minus 1, 1. This is 1. This is minus 1. This is minus 1, 0, 0, 0. This is nothing but transpose of the fundamental Triset matrix. Fundamental Triset matrix 0, minus 1, 0, 1, minus 1, 0, 0, 0, then 1, 0, then minus 1 and 1. This is 1, minus 1, minus 1, and triple 0. Yes, absolutely fine. Into IT. What is the IT? IT is the Triset matrix. This IT is the Triset matrix. Just now, we have calculated the Triset current. We have calculated the Triset currents. Is it right? We have calculated the Triset currents. Just I will show. These are the three Trisets, and its current is Ix, Iy, and Iz. The first value is 2.02. Second value is minus 3.43, and third value is minus 1.48. 1.48 amperes. Minus 1.48 amperes. This is the value of this IT, which is nothing but Triset current matrix. If we know these values, then we are in a better position to find out the values of the currents directly, which is nothing but I1, I2, and I3 in this case. Now look at how is the calculation. Yes. Just I will calculate the values here, and I am expecting the answers from your side. This I1 is equal to this first current. Multiplication of this into this means 0 into this, 0 into this, 1 into this value. This it is 0 plus 0 plus it is minus 1.48, which is equal to this value. It is minus 1.48 amperes. This is minus 1.48 amperes is the value of this current. Is it right? Similarly, I will go to the question. What was the question? Just look at what was the question. In this case, if I am coming to this question, for the network shown below, calculate current in 6 ohm resistance. We are not interested in all the currents. We are interested in the current in 6 ohm resistance using Triset. Current in 6 ohm resistance is nothing but this resistance, means branch number 4. Means we are interested only in the calculation of the current in, this may be the current in branch number 1, maybe branch number 2, maybe branch number 3. This is I4. We are interested in I4. This may be the I5 and this may be the I6. But we are not interested in all the currents. What is the question? Question asked is calculate the current in 6 ohm branch. 6 ohm resistance, and this is the 6 ohm resistance, which is the branch number 4. Is we are interested in the calculation of the current in branch number 4. This I4. I4 is nothing but this I4 is equal to, this is 4th row. And this column. This 1 into 2.02. This is 1 into 2.02 plus the 0 into this value 0 plus 0, which is nothing but 2.02 amperes, is the calculation of the current in the required branch, which is nothing but 6 ohm resistance. This is the calculation of the current in 6 ohm resistance. That's it about this problem. Is it right? There may be the extra step which can be asked. How is the extra step? In this case, they have asked for the calculation of the current. If they will ask for the calculation of the current and voltage in the same branch or in all branches. If it is in the all branches, then we have to calculate the current, that is I1, I2, I3, I4, I5, I6. But if they will ask for the calculation of the voltage in the same branch, then how will be the calculation? That I will discuss. This is the last step, which is the step number 10, or maybe the number whatever you have decided. Calculation of branch voltages. Calculation of branch voltages. Branch voltage or branch voltages. Here in this case, we are not interested in all the voltages. I am planning to find out the voltage across only the 6 ohm resistors. What is that formula? I will show the formula first. VB is equal to ZB IB plus VS. This VB is equal to this VB is equal to, how is the equation? ZB into IB plus VS. I will show once again. ZB IB plus VS. This VB is equal to ZB IB plus VS. That is the equation. VB is the branch voltage matrix. It is a column matrix. This here it is V1, V2, V3, V4, V5 and V6. Because we are interested in the calculation of the branch voltages. Is it right? It's equal to ZB. ZB is the branch impedance matrix. ZB is the branch impedance matrix, which is something like this. Just wait. This is ZB. This is ZB. This is 200 and so on. Just I will write here. Just I will write here. It is something like this. This is 2 0 0 0 0 0. This is 0 2 0 0 0 0. This is again 0 0 2. This is 0 0 0. This is 0 0 0. This is 6 0 and 0. This is 0 0. This is 0. This is 0. This is 3 and this is 0. And finally this is 0 0 0. This is 0. This is 0 and 2. Is this ZB into this IB. Here I have done little calculations. Suppose we have not calculated this I1 because we are interested in I4. That's why I have calculated I4 only. I will assume that. I1 I have not calculated. I2 I have not calculated. I3 I have not calculated. I4, how much is I4? 2.02. This is 2.02. I5 I have not calculated. I6 I have not calculated. Plus VS. Plus VS. How much is the VS? In this case, VS is the voltage source matrix. VS is the voltage source matrix. How is that matrix? It is something like this. This is that VS matrix. Matrix VS. Is it right? It is something like that. Resistors minus 6, 6, minus 10, minus 18, minus 15 and plus 10 is that value. If we have calculated all these currents, I will enter, this is minus 1.48, I will enter this value of I2. I will enter this value of I2, I3, I4 here and that matrix will be complete. But we are interested in only V4, voltage across the 6 ohm resistance or 6 ohm branch to be exact. This V4, 1, 2, 3, fourth column into this. This is 0 into this is 0, this is 0 into this is 0, this is 0 into that is 0, 6 into 2.02. This is 6 into 2.02, then 0, then 0. Is this value plus, this is 1, 2, 3, 4, plus this minus 18. Are you getting me? Multiplication of this V4 is equal to 4th row and this column. That multiplication will be 6.02 in that value plus it is 1, 2, 3, 4th element plus 4th element, which is this. Which is equal to 6 into 2.02. I will work out that calculation. 6 into 2.02, this value 12.12 minus 18. This value is minus 5.88. This is minus 5.88 volt is the minus 5.88 volts is the voltage across that 6 ohm branch. Is it right? Now how will be your solution? Our solution will depend on what is the ask. In this case, for this given network, they are asking current in the 6 ohm resistance. But here I have calculated the two values. What I have calculated? I have calculated current and voltage. Is it right? How is the calculation of current? How is the calculation of current? First of the calculation of the current by using expression, this IB is equal to BF transpose into I2, and just I have focused on I4, fourth branch. And again, for the calculation of V4, this is a general equation, and just I have focused on the fourth branch. This V4 is equal to this row into this column plus or minus whatever this value. Means which is 6 into 2.02 and plus this minus 18, which is nothing but minus 5.88 volt is the value of that voltage.